Hello, everyone. I am Nathaniel Bauer. I'm a project manager here at Wolfram, and I work in the Strategic Partnerships and Developer Relations group. So I'll be the main presenter for all of this, but we also have several other partnership associates in the chat. So feel free to ask questions, write comments. If they don't, or if I don't respond to the comments verbally during the presentation, they will most likely be able to respond to the comments just during chat. I'll stop a few times during the presentation, just if you guys have questions on a specific thing, and then we will also have a larger Q&A kind of towards the end. All in all, I think this will run about 40 to 45 minutes, sort of depending. So with that said, let's get started. All right, so if you are unfamiliar with Wolfram, I'm just going to give a quick little rundown of us. So we're Wolfram Research, and we're a global leader in computational technology. We were founded in 1987 by Stephen Wolfram, and our mission is to make the world's knowledge computable. And so that means that we want to turn data, models, algorithms into universally accessible computation. And the main tool for this is the Wolfram language. So it's a full-scale computational language. It unifies data, math, visualization, AI, natural language, all into a single cohesive package. And you'll see it in products like Mathematica, Wolfram Alpha, and everything else listed here. We have a much larger offering than what most people realize. And the one that we're going to talk about today are some of our APIs and our platforms to deliver this computational intelligence to both AIs and to humans. So we do that through tools like the Wolfram Alpha LLM API, the Wolfram Language API, and we have like an LLM kit for ChatGTP or for LangChain integrations. And we serve a broad audience from public sector, private sector, engineers, researchers, educators, data scientists. Wolfram is all over the world. So as the crux of this, why should you integrate Wolfram, right? That's kind of the main goal when we talk about this webinar. What are the benefits? And the main benefits of using Wolfram and using our APIs in your LLM tech stack is to ground its output in factual data and precise computation through a variety of additional functionality. So Wolfram is used across hundreds of industries, but it's often sort of behind the scenes. For example, if you've ever seen Interstellar, some of its Academy Award-winning visual effects were computed, tested, and visualized by Kip Thorne, who was the astrophysicist consultant, and he was using Mathematica. He was using Wolfram language to actually create those and then pass them on. And when we're talking about using Wolfram or sort of the Wolfram APIs, we're really talking about two separate APIs. We're talking about the Wolfram language, and then we're talking about Wolfram Alpha. So they're an interconnected ecosystem, right? Anyone familiar with Wolfram knows that they aren't siloed. Wolfram language provides raw computational power and code. And then Wolfram Alpha is sort of built on top of Wolfram language. It's a Wolfram language program, but Wolfram Alpha provides more context and data around the query. Okay, so just with that summation, let me dive a little bit deeper just to kind of highlight the differences between Wolfram language and Wolfram Alpha. So Wolfram language is a symbolic programming language, right? And that means that it allows for the manipulation of mathematical expressions and structures directly rather than just like changing their numerical values, right? It's a deeper level. And it's a unified system. So computation, visualization, and documentation are all built into it. And it has a consistent structure and design. So it has a unified syntax, like unified naming conventions, common data types. And all of those function across a wide range, apologies, of operations and functions. And we like to automate wherever possible. So we have high-level functions that encapsulate these really complex computational processes. And one of the main benefits of this is that you can significantly reduce the amount of code required when you're using Wolfram language because it's very compact and precise. And Wolfram language is, I don't want to say complete because it's always being added onto, but unlike a lot of other languages, there are no other packages to call, there aren't other libraries to call. And through the function repository, we continue to explore special niches, and then we take those and pull them back into the main language to continue developing it. So Wolfram Alpha is, as opposed to like the targeted focus of Wolfram language, Wolfram Alpha is much more about data and context around the query. So Wolfram Alpha is a computational knowledge engine that accepts natural language inputs, like you see here, parses them, and then it dynamically computes results from curated data and algorithms instead of just returning web pages or just a standard web search. So for here, it's not only answering the question of the cost of 300 kilowatt hours of electricity in Minnesota, but it's also providing the historical information and visualizing it. And then it also has it by sector. And there's some other information if you actually look on the Wolfram Alpha page. But both Wolfram language and Wolfram Alpha have access to our knowledge base. And this is one of the key features of our APIs. So the Wolfram knowledge base is our curated and like semantically structured repository. So it contains trillions of data points across hundreds of different domains, all of which can be used by both Wolfram language and Wolfram Alpha, like I said before, if you want to look at facts or entities or just do computation. So to give you an idea of the breadth and the depth of topics that we have in the knowledge base, we have things like comprehensive computable data, all of which you can do visualization and computation on. We have geographic data, physical science data, biological and life science data, food, nutrition, and physical activities. So even really niche things like the Scoville levels of random hot peppers, right? That's in our database. We also have business use cases like finance and business data and more esoteric things like art or social cultural data. And in addition to these sort of raw facts, we also have parameterized models and formulas. And all of these and more, obviously, can be pulled into Wolfram to enhance your LLM's output with actual data and compute that's grounded in reality as opposed to just standard hallucinations. So let's talk about that. Let's talk about hallucinations. If you've followed the industry for any amount of time, you'll constantly see stories about LLMs, right? You've seen probably things like paid human intervention to correct bad outputs, or in July when Replic's coding agent deleted an entire production database. Whoops. Air Canada's LLM chatbot, which just hallucinated legal terms that they were then held accountable for. And another recent one was Gemini just invented a new body part, and that wasn't caught by the researchers or the peer reviewers and made it to publication, which is definitely a little concerning. But all of these are just examples of LLM issues. So things like hallucinations, transparency, contextual memory, inconsistency. And unfortunately, these aren't really going away right now. Recent research, even from top AI firms, this is from OpenAI, and this is September 4th, um, they're basically, there's just the acknowledgement that AI hallucinations aren't just engineering flaws, they're mathematically inevitable. And even though we see tons of progress with new models hitting the floor every month, there's still hallucinations and they still exist in the presently in the latest models. So enter Wolfram. While we can't resolve all of the issues with LLMs, what we can do is we can help alleviate some of them, especially in areas that LLMs and generative AI typically struggles with. So I'm going to talk about two APIs. The first of which is this one, which is the Wolfram Alpha LLM API. And this is all the power of Wolfram Alpha, but it's specifically designed to integrate with large language models. So the LLM API essentially is built to provide like trusted computation and then factual data to anchor your model's responses. So let's just talk about some examples, and then I'll get into the kind of the technical meat of it. Here's an example with just an LLM, and I did this September 15th. So an LLM with web search, the typical thing where you go to ChatGPT or wherever, you put it in, it does a web search, it gives you the result. So I ask, what's the price of gasoline in Dallas, Texas? And it reports it back and it says, oh, it's $2.94 per gallon. And it does this because, like we said before, it does a web search and it finds an article written on September 12th, 2025. It says, hey, here it is, boom, and it serves it back. But if I do the same search with Wolfram Alpha, it's going to give me a different, so this is for Monday, September 15th again, and it's going to give me a different number, which is $2.87 per gallon. And this is the actual one. The problem with web search occasionally is that it's going to be pulling from random data and then bringing it back to you, but it might not always be up to date. So when you use Wolfram Alpha, it has direct access to our knowledge base and to all this information. So you can grab authoritative answers, or like you can grab answers from authoritative sources and then serve that up to your user through your LLM. So here you can see it says talk to wolframalpha.com. And so let's actually look at the query and look at the call so you can see what's going on like under the hood. So the Wolfram Alpha LLM API queries are sent using GET requests. So for example, here is the query for what we just looked at, which was the price of gasoline in Dallas. So there's three parts to every query. There's the base URL, which you see here, and you can see on the right, it's calling the LLM API. And then there's the input itself, which here is the price of gasoline in Dallas. And finally, there's the app ID, which is part of the security and part of the, dropping a word here, sorry, like it's part of the authentication process. Whew, there we go. And so this is what it looks like. And I can actually show you exactly what that looks like when you call it. So this is, well, this will be for today, November 7th, or no, Wednesday, November 19th. But it's going to call it and it's going to pull all this information for your LLM, which it can then pass back to the user. And all the LLM API queries are structured like this. So for example, if I wanted to know, what are the 10 densest elemental metals, it would be the exact same breakdown, the exact same three parts. So the base URL, the input, and then the app ID. So let's actually look at that because that'll have a little bit more interesting data for us to play with. So on the left here is the Wolfram Alpha, is like the actual query. And what it's essentially doing is it's taking what the Wolfram Alpha input or output would be, but then it's providing it in LLM form. So let me just put it on the screen so we can kind of visualize it and interact with it. So here's the response from the API for the 10 densest elemental metals. And you can see it provides them all here. And all of these responses, if there's visualizations, it'll provide a link back to the visualizations. So in this example, right, it's showing the periodic table of elements, and then the images for who the elements are named after. And all of these will also have a link back to the Wolfram Alpha result right here. Okay, and I know this font is a little small. Apologies, it's hard to put, I can't really fit all of it into a single thing. But as a reminder, this material is all available for download. So while we're running through this, if you want to follow along in, in the presentation itself, that's totally fine. Otherwise, I'm happy to go into specific details a little bit later on when we stop for questions. So here's what one of the API responses is like for the 10 densest elemental metals. And an important thing to note is that the LLM API enables, or it allows for additional customization, both through parameters and through prompting guidance to your LLM. So you can really tailor the output to your specific audience, application, or really whatever your use case is. So we're going to talk about examples, and we'll run through an example, and then we can kind of take questions and discuss the LLM API a little bit more. So what does using the LLM API actually look like for someone doing this? Let's say, for example, you have a user interested in commercial real estate, and they want to do investment, and they're looking at Austin, Texas. So they're using an LLM, and they're chatting with it. And the truth is that for simple information, an LLM can handle quite a number of requests. So say the user wants to start looking at the unemployment rate in Austin, Texas. So they ask it, and the LLM alone says, okay, here's the unemployment rate. It's about 3.4% because it's seasonally adjusted. And then it passes it back to the user. Wolfram Alpha, if we do that, does the same. And so this is what the query would look like. So what's the unemployment rate in Texas? Here's the response, but let me show you what it looks like when it's passed back through the LLM to the user. So it provides, ours is non-seasonally adjusted, which is why it's 3.3%. But we provide the same information, right? Except that we also have the visualizations and the historical data. So the user can go, okay, here's what it is at 3.3, but then they can also see, oh, what's that? Oh, that's COVID, there's the COVID spike there. And it actually seems like overall the unemployment rate is kind of going down. But this is that sort of deeper level of information and trusted information that the user will receive. But for the user who's a potential investor, something like, oh, just the unemployment rate really isn't that much information. However, our LLM API provides a wealth of additional context and additional data about the area, all from a single query, just if you're asking about Austin, Texas. And it doesn't need to burn through compute and time to find and report and compile all these sources. It's just done with a single API call, which then comes back to the model, which it can send on to the user. So this is what the output looks like. It's way small, so we're going to blow it up again just so that you can kind of see it. So the query is Austin, Texas. And it provides a ton of information, which just in our example use case of, hey, I want to learn more about it because I'm interested in investing, it provides a ton of information like the population, its location, even the local area, a local area map for it. And on the more economic side, there's things like the educational attainment, who has a college degree, who doesn't, what is the median household income and other income statistics, the economic properties, so things like the median home price and sales tax. And then there's also smaller things that would be interesting and or could potentially affect this user. Things like, what are the nearby airports? What are the nearby hospitals? Or notable company headquarters? Who is actually headquartered here? And would that play into their decision? But again, all of this is real data. it's pulled from various data sources into our knowledge base and then grabbed from your LLM and sent to the user, and they can trust it, which is one of the most important things. And there's random things that are less important but still kind of fun to pass on just if your user wants them. So things like the Wikipedia page hits over time. And with all of these, there's a link to back to Wolfram Alpha. If you don't want that, this is a type of thing that you can customize out with prompting and just say, hey, don't return the Wolfram Alpha website. So beyond simple data, which is kind of what we were looking at there, just pulling back data, the user who's interested in real estate in Austin can really use Wolfram to just explore tons of different things from our database and then pull them all in together. So you can look at things like the real estate indices, right? So the median home price or the home price index, home price value, the number of homes and their aggregate value. You can look at economic indicators, right? So mortgage rates or like the rental vacancy rates, apologies. And there's more, there's the public company financials. So for those companies that are headquartered in Austin, are they doing well? Are they rising? Are they falling? What do they look like? And, what does their stock look like over the last year, 5 years, 10 years, etc. And all of that information are things that you can plug into Wolfram's time series and do trend analysis on. So you can say, hey, their stock is doing good here, but what is it like? What has it been like historically? Or home prices are low, but historically they were high. But that's all functionality that our APIs can deliver to your users to ensure that you have like a superior output. And in addition to the chronological, well, not chronological, but the time series analysis, you can also do geographic and demographic analysis. So because Austin is a city entity, you could actually look at Austin and then the user could say, oh, I wonder, what about this information for Philadelphia? And all it needs to do is swap the entity Austin with Philadelphia and provide all that same information, all that same depth, so that your user can easily compare. And that's all done with just simple API queries that are then passed back that your user can trust. So that's data. And we talked about all these different things, but you can also move to actual mathematics and calculation, which is something that LLMs, as we all know, have just really struggled with. Even though they've improved slightly, there's still quite a few problems with it. So we are a reliable source of computation. I think we've been a reliable source of computation for several decades. But let's say that our example user has decided, hey, I'm going to invest in Austin and I'm looking at this building and I need to look at what mortgages would cost. So let's say that they're going to ask, they're going to ask the LLM, what's the monthly mortgage rate payment for a $420,000 loan, which is the median home price, at 6.25% interest over, say, 30 years. So here's the response with Wolfram. And you can see it says talk to Wolfram Alpha at the top. So it's going to provide the loan summary information, which answers the user's question, right? It's like, hey, your monthly payment's going to be $2,586. And then it's also going to provide additional things. So interest versus principal. So the user can look and go, okay, the principal is 420, but with these rates, I'm going to end up paying over $500,000 in interest, right? And it can visually display it for them. And it can also display things like the amortization snapshot. This is just the first 5 years, but if you wanted, you could prompt the model to deliver the whole thing, or you could have it linked to Wolfram Alpha, like we said before, so they could see, year by year, what that breakdown is, what's the interest on principal, what's the yearly paid interest, etc. And so this is another aspect beyond data where we really shine, where we can not only pull those mortgage rate data, the mortgage rate data or the home price data, etc., but we can also do calculations on it. We can actually provide trusted mathematical answers for your users. And so beyond that, if you start really getting into calculation, Wolfram language provides an even deeper computational strength and functionality. So just for example, if we have this user who's looking at real estate in Austin, and they're like, okay, but I want to think through what could potentially happen here. They could plan Monte Carlo simulations for a rental property, looking at all sorts of different metrics of, okay, it's only rented for 75% of the time, or, I miss a loan payment, or I do more, all these different things. You can see like monthly expenses for maintenance, vacancy, management, etc. They can run all of those questions in a Monte Carlo simulation in the Wolfram cloud. And so that's what we're going to talk about next. However, I understand that I've just kind of been plowing ahead. So let me stop before we talk about the Wolfram Language API. And let's just maybe look at Q&A really quick for any of this. So if you guys have any questions about the LLM API, shoot them to the Q&A or put them in chat and we can answer them. I see, can the LLM get a list of results? Researchers for what, Latif? So it'll pull from Wolfram Alpha. So if you're looking for researchers for all sorts of things, we have all sorts of data for that. But if you can clarify it a little more for exactly what you're looking for. Okay. I don't see any other questions. So if you do have them, don't worry, we'll have another Q&A at the end, but I just wanted to stop. All right, so I just wanted to stop and then keep going now. So now we're going to dive into the Wolfram Language API. And if you remember from the beginning, we talked about how Wolfram Alpha is more sort of data and context, and then Wolfram Language is more like targeted, because it's essentially using the Wolfram Cloud and directly calling Wolfram Language. So think of it as a direct interface to the Wolfram language. And if you're familiar with Mathematica, sort of like a direct interface to a Mathematica notebook. And what it does is it allows your AI to sort of act as a computational agent for expert level calculation, modeling, and analysis. So what does that actually look like instead of just saying fancy words? Say I ask an LLM to plot the intersection of this expression right here, right? And here's the result. And then I can also do the same with from. And there are times when the LLM will get simple plots correct, and there are times where it won't. And this is both good and bad, because for a user who is not a subject matter expert, there are issues where like where the user will just get the output and they'll say, okay, yeah, this is correct. This is what the plot looks like. But because it's a hallucination and the model doesn't say, hey, I'm not really sure about this, it just responds back to it, you could be serving erroneous responses to your users, which you will not be doing with Wolfram language. And in terms of what this looks like under the hood, so this is essentially running on the Wolfram cloud. If you're familiar with our cloud notebooks, it would kind of look like this. So here you can see it's calling region plot for the expression, and then it's actually running it and generating the plot here. And then this plot is returned back as a PNG to your LLM, which then returns it back to the user. But an important thing to note here, you can see just how small the function for region plot is, right? The Wolfram Language API gives you access to thousands of high-level functions like region plot or even more complicated ones, and then it can evaluate all of them. And like I said towards the beginning, Wolfram Language is super compact and super efficient. So especially if you compare it to something like Python, you're going to be running much, much lower token counts in comparison, which if you're looking at an enterprise use case will really help keep costs down because we're much more efficient and just condensed. So for a deeper technical dive, there's really a lot. And so what we'll do is send out the documentation or maybe link the documentation for the Wolfram Language API. I'm not sure if someone can do that right now if they have it on hand, but I just want to talk about some of the key points with it. So, first of all, like we discussed previously, the Wolfram Language Evaluator API, or just the Wolfram Language API, supports the full Wolfram language, and its outputs are in JSON or they're in image links, similar to the plot that I showed you at the beginning. And the API is stateless, which means that you can include the precise context for each query to it, and it doesn't need any of the surrounding stuff. So you send everything with it, so you can precisely get what you want. In terms of data, any data that isn't in the Wolfram knowledge base, you can include. You just need to fetch it via an API input or by using Wolfram code. And we are scalable. We're in tons of enterprise use cases. So if you have large or custom data sets, we can, like the Wolfram Language API can allows for like persistent multi-request workflows and analysis. The queries for it are going to look slightly different. Unlike the Wolfram Alpha API that you saw at the beginning, which has the kind of those three things of the base URL, the input, and then the authentication piece, or part of the authentication piece, the Wolfram Language API is a REST API, and it's hosted at Wolfram Cloud, and access to it is granted through a bearer token with the API request. So for example, a really basic, here's 2 + 2, right? It's gonna throw it here, and then at the bottom you can see it has the bearer token here, which is just a fake Wolfram token 1, 2, 3, 4. The input should contain the Wolfram code to be evaluated as an encoded string, and you can have line breaks with it. So you can do this as a post or a curl request, and that's a line break example right there. But we generally recommend that you use post requests if you want to try to accommodate like really large expressions. Okay, moving on. What do the results look like for our super basic 2 + 2? It's the same as if you ran it in a Mathematica notebook, right? So it just says, okay, 2 + 2, the output is 4. So it's returned generally as a string as the value of the output key. And then for like graphical expressions or plots or anything else, the API will run it, and then, like we talked about previously, upload a PNG to the cloud with a link to the output, and then that's how they pass it on. You don't have to pay for this cloud storage or anything else. It's just hosted by us for now, and I actually am drawing a blank. I think they're deleted after 90 days, just so that's a consideration. But the other cool part of this is that while this isn't dynamic, it returns the Wolfram language code. So the user could then take the Wolfram language code and run it in a notebook themselves if they wanted to look at, say, if they wanted to do a manipulate or a compute or something similar. And now that we've talked a little bit about the technical side of it, let's talk about the actual use cases, because I think that's a much better way to really convey like how it would impact your users or how it could impact your platform. So we're going to start with some edtech examples. Say you have a student who is exploring chemistry, right? And you have an application like a private tutor or something else in the edtech space that has an LLM that's calling our APIs. And they're going to ask a question like, oh, show me the structure of ATP. And an LLM alone, if we look at this example, is actually going to get it mostly correct. There's a few issues here, like the hydrogens, the H's shouldn't be red, and the OH groupings on the left over here are like too close together. That but it's relatively close, right? But we can do the same thing, but instead call Wolfram language. see it says talk to api.wolframcloud.com, and it shows it here. And so this has the hydrogens not as red, and then they're spread out a lot better. But this is sort of basic, right? Both OpenAI and Wolfram use RDKit under the hood. However, this is a single call. And so for basic stuff, they're fine, but Wolfram has additional code and support for it. We've spent decades building up our chemical intelligence. And so as you start to move from really simple things to more advanced things that the students might struggle with, that's where we really shine. So say, for example, I want to take this structure, but instead display it 3D. Your user says, okay, I kind of understand this, but I want to see what it looks like in 3D. So if I ask an LLM alone, the first time I prompted this, it actually said, hey, yes, let me render this in 3D, and then didn't give me anything. But I did it again, and this was the response. So it's like, oh, I rendered it in a static 3D ball and stick view, which if we expand out, we can see the actual structure is mostly correct, but it's not 3D and it's not very readable at all. Whereas if you look at what it looks like when you do it through the Wolfram language API, the response is the actual 3D structure, which is correct, and it shows the code below. So something that is very difficult for a lot of students, right, if you're in ed tech, is in chemistry, moving from 2D to 3D, right? And so they actually have the code now. So while they can see the static image, they could also do it in a manipulate in Wolfram language and then look at all the different parts of it and really play with it to better explore it, which is a vastly superior output if you're in ed tech than what you see on the left here, which is the 3D, but not really 3D output. And it's like this for tons of other ed tech use cases. Oh, sorry. We've spent, like I said before, we've spent decades building up our, chemical and scientific intelligence, all of which is in the Wolfram language. So here, for example, are just some of the functions we have for molecules. And these are all things that the Wolfram language API can call if you're in a use case like EdTech and you have someone studying chemistry, or if you're doing research, or tons of other use cases can all call this and then use it. But keeping in with the EdTech theme, let's say you have someone who's looking at astronomy. And so they're going to ask a simple question like, oh, how far away is Mars? Or sorry, how far is Earth from Mars? And an LLM alone is probably just going to do a web search like you see here, and it responds back, oh, it's about 349,000 miles. These numbers aren't quite accurate because I did this, I think, at the end of September. So the real numbers right now will be slightly different if you look at them online. But what was interesting is that it did a web search and it actually cited a source, but the number that it returned was not actually correct. So it's 352. But the number that it returned was 349, which in some instances might not be a problem, but if you're in any sort of actual STEM field, those numbers and those differences are incredibly important. So if we run the same thing, but with Wolfram language, we can see, oh, and actually this is a thing I should point out. See where it says error talking to connector, talk to Wolfram API, talk to Wolfram API. If the call fails, the API actually responds back and says, hey, are you trying to call this? If you are, use this function. No, that's not. Okay, are you trying to call this? Use this function. So it's self-correcting. It'll send back error codes and information to your LLM to say, hey, if you're trying to do this, here's what the call should be. And then this is the actual correct one, right, which is 352. So that's astronomy. Another EdTech use case that's super obvious is mathematics. We don't have time to dive into tons of examples, so I'm just going to kind of run through a lot of what we've seen to be use cases, and just sort of like the width of our functions that your API can call for mathematics. We have probably one of the most complete collections of mathematical functions. So everything from like elementary functions to special functions to like piecewise and generalized functions, integer functions. If you're doing computation, we have everything for that as well. So symbolic, numerical, asymptotic, and as you can see, there's images for all of these. So all of this has function visualization for it. So you can call it for this. So you can imagine if you're in, say, the edtech space, as opposed to an LLM just responding back randomly with things that may be correct or may not be correct, but the student wouldn't know because they're learning. This is where we really shine in these kind of like STEM fields, or in these, more sort of like hard science fields. With that said, it's not like we're limited to edtech. We have industry use cases for everything. So you'll see us in finance, in real estate, in medical research, in epidemiology, energy and natural resources, manufacturing and engineering, public policy and government, environmental science. And all of these have specific use cases that we can help better your use of generative AI, either for an internal service or for a public-facing, end user experience. But beyond sort of the high-reaching things, we're also great to integrate just into smaller, simpler platforms. Like if you have a chatbot that's focused mainly on just daily life or conversation with a user, and you want it to stand above other LLMs or other responses, we can also augment that data and that use case as well. So, say for example, I'm in Champaign, Illinois, the headquarters of Wolfram, and I'm sitting outside and I see a plane fly over my head. And I'm like, oh, that's cool. I wonder where that's going, right? So I say, hey, I'm in Champaign, Illinois. What airplane just flew over my head? So an LLM alone, this is an example where it didn't find it. There are some times where it can find live tracking data depending on the LLM, but as AI information kind of starts to get a little tweaked, there's some parts there. So I will say that I have occasionally found it'll say, hey, there's probably an airplane going overhead or something else. But here's an example response where it doesn't find anything. And it's like, hey, instead, you should try to find this flight tracking data. Whereas if I call Wolfram and do it, its interpretation is, oh, flight seen from Champaign, Illinois at the current time. And it's going to list not only these 5 flights, but it's going to say where they're headed, their altitude, their angle, and it can even visualize it for us right here. So we can see, oh, here's where all of these are going. Beyond that, other simple use cases, something like how long will it take me to sunburn if I'm in Champaign today? And the LLM response does a semi-decent job, right? It's like, oh, there's the Fitzpatrick scale, which defines your skin tone, and then the UV index. So depending on what the UV index is and what your skin tone is, you might get sunburned, and then there's some other modifying factors. When using it here, Wolfram is going to pull in the information and show you, oh, here's what the Fitzpatrick skin types actually look like. And here's the actual time to sunburn based off of that. And instead of just saying, oh, if the UV index is this, it looks at the UV index, right? So you can see it pulled the UV index for Champaign and says, hey, here's what it is. So the user can look and go, okay, the max is like 6, and then they can get a much better understanding of it. So as opposed to just the smaller, simpler response, you have a more concrete response, and it says, hey, if you put on sunscreen, you probably won't get sunburned. Overall, it's just a stronger user experience. Oops, sorry, I did not animate that correctly. So just other examples, like small things like percent tips or earthquakes or humidity, all sorts of smaller things that a user might have if it's just a sort of a chatbot use case are all there. So in summary, if you want to do enterprise use cases, or if you want to do, smaller scale, sort of like daily life chatbot use cases, we slot into both of those, and we can really help improve your generative AI offering to whatever your user base is. So if you are interested, Both these APIs are free for testing and development, so please reach out to us. You can also just we linked this at the beginning of the webinar, but the developer.wolframalpha.com, if you go there, it's the page that you see on the left right here, so you can sign up for free. You just need name, description, whichever API you want access to, and then submit that. If you have any questions, or if you want to talk about your use case, or after you've played around with just the testing and development side of it, if you do want to put it in a commercial application, feel free to email us at partner-program@wolfram.com, and we will be more than happy to talk you through all of it.